Okay, today we're going to talk about printing and building this Pogot Color wheel version. Hopefully we'll also test 3 different types of motors, and hopefully I won't forget, but I've also found a couple more sources online for the 1:220 gear ratio TT motor. So we'll kind of get into all of that. But basically, a lot of this has not been screwed or glued together just so I could take it apart. If you haven't watched the other videos, this is what we're dealing with here. You have a walking robot, and you have a changing color dial in the chest. It's operating from 2 AA batteries, 3-volt system. So let's start, let's take the head off. Normally I would glue the head down on, but again I wanted to be able to take all this apart. There are 3 different hat variations. This is the domed one, then there's a more flat one like the original Pogot toy, and then there's a flat one with a hole for an antenna to come out. There's 3 different types of ways you can do the eyes. There's these ones which are just solid. And there's ones that have 3mm holes in the center for 3mm LEDs, and ones that have 5mm holes for 5mm LEDs. And if you don't put this part in at all, which is this part, of course this is one with holes in it for LEDs, you can then put in 10mm LEDs, which is a standard size. These parts are already glued in there. They glue in from the inside, so when this is open you actually have not only this opening, this opening, this opening, this entire top is an opening, and the ears are opening. So you have lots of ways you can get your fingers in there to glue those parts in from the inside. And the reason I made all those parts separate is you could print them in different color material. In my case I'm working in PLA. The top hat part, though, if you're wondering what's going to hold that down, since it's just a big hole in the top of the head. So here's one of the flatter head tarps. There's this piece here with lips that glue in from the inside. I actually insert it from the top and just push it up with my finger, and the glue goes on these little ridges and forms a platform that then this piece can then glue onto. Again, I made all those access holes that way just to make more room to get in there in case I wanted to put electronics in the head. Or maybe I want to put a motor in the head. Who knows? But it was one way of putting all of these parts on to get color difference without having to use a paintbrush. You could print all the parts in separate colors. This neck ring here will fit into the top of the body. I normally put a little drop of glue there and just squish it down in place, and then it's not going to go anywhere that way. Here, for example, is one of the mouthpieces printed in black. You can see it's got the picture frame where you put a little bit of glue around there and insert it from the inside and glue it into place. The color wheel. On the original toy, the color wheel only had 2 colors. So the first one that I made was this one, where it just went black and white, and it actually looked pretty cool. This piece, this gray piece, prints flat on your printer so that this decorative side is facing up. You have to have supports around this edge here that you just peel away. Now obviously this ring is printed as a separate part, and on that part there's 4 pie-shaped wedges. One of the wedges is part of this ring, so whatever color you print this, that's going to be one of your main colors. And then the other wedges, which you glue in place, you can print in any colors you want. In this case, I printed those in black and glued them in. But as soon as I saw this and thought about the original one, I went, you know, why should I just go with 2 colors when I could make each one of those wedges a different color and go with 4? Now this ring piece itself, on this first one here you can see, actually 3D printed a pin piece, which this has to spin freely on, but this can glue in. You can see the front of it right there to hold that in place. Then there's another little pin that you glue in there that has to do with moving it. And you don't have to use the pin and glue it in. You can just use a screw as long as the screw head is very flat and doesn't protrude out too far. If the screw head sticks out too far, it's going to hit what's going on inside the body in here, and this won't be able to fit in all the way, and you'll have a problem. But this one works just fine, as you can see. It would allow me to take it apart. Let me get a screwdriver. And I will actually take that apart so you can see the pie-shaped wedges. There we go. So there we are. This white was this main piece that prints flat like that, and then these were separate little wedges which I 3D printed and then just glued them in place. And of course the post, the gray post on the back, has to do with the movement of the whole assembly. And here's what this looks like without that wedge on there. Again, prints that way, supports around the edges. Okay, so on the inside you've got a gear right here. Boy, that sun's maybe gonna goof up the camera work. There's a pin on this gear, and again I used a post in this case to hold that gear in place. It has to be able to move freely. I almost can't see what I'm doing, the sun is so bright. Let's try that. I don't know if that'll be better or not. But again, you can use a 632 screw as long as the head is very flat. But the screw can't be real deep. It needs to be less than a 1/4 inch deep, or it's going to end up hitting the TT motor in there. So let me turn this on now so you can see what's going on. I'm going to show you better what we're looking at here, but the TT motor shafts are sticking out here with the cams. This gear spins this gear, and this gear is what spins this gear, and that little button that my finger's on is what touches the button on the color wheel to make it turn. Now the arms aren't moving right now because I've lifted the body up. See if we can get enough light in there so you can see that. See that screw in there? There's a post. That arm linkage would normally... Is it impossible to hold all this? I'm going to have to, I can't look through the viewfinder and do this. I'm going to have to look this way so you can see how that arm linkage piece fits on there like that. And that's what provides your arm movement. You're going to see all that better here in a minute because we're going to take the body off. We're going to try different gear motors in this thing and see what everything looks like. This arm linkage I didn't hook up because when I lifted the body up, it came off, as you can see. So there's your TT motor. Here you can see how much room the battery box occupies. Again, I wanted to make this so I could put in as many as 3 batteries if I wanted, or 2. So it occupied an immense amount of space in this whole thing. Let's heat up this little soldering gun here, and we'll take those wires off. Just let that warm up. So there's on these legs that come up, the piece that I've got this screw screwed into, it's just a 1/2 inch 632 screw. This is a separate little piece which you just put glue on the bottom, and it simply glues to the top of this leg piece. I could have made it part of the leg. You could have printed it all as one, but there had to have been an awful lot of support material on there, and it would have taken more time, more plastic that you're going to throw away in support material. It's a lot quicker to just glue it on there and be done with it. So that's what I did. Now let's pop these motor wires off. Free that up. And let's put this guy back in hibernation mode. There we go. Alright, so now I can handle this a little bit easier as I don't have the battery wires on there. Well, let's talk about the battery wires before we go much further. So again, I haven't glued the battery box in or anything like that. It's going to fit in there. The two wires go up. Just take one of the two battery wires and run it through your switch so that you can open and close one of the connections. In this case, I made it the positive wire that would just open and close. You got your negative wire. I've extended them longer so they could reach different motors for our testing modes here. Maybe I'll just tuck all this stuff up through the neck hole. So when we start trying different motors, it'll be a little bit easier. I'm going to put the battery door back on to keep those batteries from falling out. The battery door, I guess we might as well look at. It's printed as 3 parts. This outside part prints flat on your printer like this. These 2 little pieces here require supports. This piece that slides doesn't require any support. It prints out here flat, and the knob prints flat, kind of like you're seeing it right now. Even though it has a cutout up in there, it's flat. Your machine can bridge it. It doesn't require any supports. So when you go to assemble, you put this piece in, put some glue up inside the knob part, and just push them together till they're nice and tight. And you should have the slide action like that. When you print the body, you might as well talk about it now, right? When you print the body, it prints upside down. So this, what we normally would think is the top of the shoulder, is going to be on the print bed like that. Enable supports, I do it manually, where you paint in where you want them. I put supports there, right there, there, and there, and then right there. Don't really need to support anything else. Maybe I should take an arm off while we're talking about all of this so you can see how all of this goes together. What I'm taking out right now is a 632 screw. It's roughly a ½ an inch long or shorter. It doesn't even need to be that long. So this is the arm linkage piece, which simply goes in to the inside like that. And then there's a flat ring spacer that drops on like that. And then there's your left and right arms. And you do need supports inside this little hole. The arm prints flat like this on your machine. And you just pop that out when you're done. And the arm should fit snugly onto that post. Put in your screw. I don't know if 632, I'm not in the land of metric, but I imagine a 3.5 millimeter screw is pretty close to 632 here in America. But maybe 4 millimeter. You'd have to experiment with that in the land of metric. But I normally like to tighten this down pretty much all the way and then back it off. So I'll take it, tighten it down. I know everything's pulled together. Everything should move freely even when it's completely tightened down. It's just that you wouldn't be able to adjust the arm position too easily. So normally you want to then go back in there and just loosen that up just a little, because then you can position. If I were to hold this inside part, I can move this arm separately without breaking anything, is the idea. You don't want it so loose that it flops around on its own, but you do want it tight enough to stay where you put it. Alright, let's get this battery door back on. We've talked about the body, the battery door, the arms. I think we're talked about everything we need to talk about there. What do we want to tear apart here? Let's take a leg off. I need is a small something to push here. For the axles in this thing, I ended up using 3 millimeter. In this case, I used brass rod. I could have used 3 millimeter aluminum rod, which is cheaper and much easier to cut. But I had the brass rod, so that's what I used. And also, 3 millimeter rod is very close to being the same as 1/8 inch rod here in America. So if all you had was some 1/8, you can use that, but you'll probably have to take a drill bit and clean things out just a smidgen, because 1/8 inch is just slightly larger than 3. So these two rods that I'm pulling out right now, they're roughly 70 millimeters long. But the point is, this base piece that we're going to strip down to and look at it in a second, you want this rod to be able to fit from side to side without sticking out, because the body has to fit down on that. And let's poke that out. Okay, with that out, you can then lift the legs off this whole lower base assembly. Now this base prints like you see it right here, just like that. I'm trying to remember. I believe I enabled support for these two places right here. But other than that, it doesn't require any support material. It's a cam on both sides, the same file. That pushes on there, and you make sure that the one that's pushed in here is, 180 degrees out of phase with the one on the other side, so you can get the walking. This large gear fits on there too, and I end up putting, you don't need to do this, if your cams fit nice and snug, like I have these, I actually took an X-Acto blade and kind of, were fitting too tight, and kind of cleaned that hole out, the D-shaped hole, until they fit just snug. I could have just glued this gear on this side to that cam surface, as if I wanted to put that gear over here. Could have put some glue there and then pushed the gear on and been done with it. But I had a little screw left over from something I bought at the dollar store in a washer, so I went ahead and just stuck a screw in. As long as it threads into the hole in the TT motor, you're good to go. Just to hold that on. In case I wanted to take it apart, I could just take the screw out and pop the gear out. And so this purpose of this whole gear is we're just trying to transfer power from this side to the middle for the chest drive. So this gear in between, I don't know what to call it. I'm just call it the small gear, but it's basically an idler gear. This one drives that one, and then that one allows us to drive this one at an angle. In order to swap motors out, I'm going to have to pull at least this little gear out. And again, you can use a 1/2 inch 632 screw or whatever you got laying around. Whatever screw you end up using needs to be able to spin free into this hole. This actually looks a little bit longer than half. As you can see, as long as it'll spin on there free, you're good to go. And it's actually using one of the motor mount holes to hold that gear in place. Then here's this one on the front, which I talked about earlier. It got a post that I glued in. Again, that could have been a screw, as long as the screw wasn't so long that it would start pushing against the motor housing and causing a problem there. So let's set that down. You don't really even need all the other screws that I have holding the TT motor in place, because it's not like it's going to go anywhere. I mean, that one would pretty much hold it. But now that motor, I haven't tried this, but let's see. I got all the screws out? I think so. There we go. So now we're down to the housing. Because that's glued on, I can't take that gear off. But this one was, I should mark that so that we don't get these confused. This would be the 1x2 20. We'll set that over here. Let's grab, for the heck of it, here's a 1x120. Slide that down in there, and let's put just the one screw in. It'll be interesting just to see what happens with different speeds of the motor, whether the toy has a problem or whether it will work. We'll find out. You don't want to tighten that down too much. You want everything to be free. And I guess now we got to put the legs back in there. You got your main hole in the leg here. You've got your back leg support piece. I'm trying to be careful not to lift this part up, this foot part up, because there's rods in there that are holding all of that together. But here's this back piece. Here you can see now how this piece is glued on, like I talked about earlier, to make the arms move. Take that. Let's grab one of these rods. Let's work that in. Let's get one side kind of set up here. Sorry if it's off camera, but I gotta have it where I can see what I'm doing. There we go. Got that coming through. Let's get the other leg. See how this just kind of horseshoes around that cam, like that. And I'm just trying to line up the leg holes with that rod. There we go. Pushing that in flush. Now let's try to undid this side. The rod slid out. Alright, I got the rod back. Got that. There we go. Alright. Maybe we can test walking speeds without putting all this back together. I don't know. Let's find out. I won't bother to try to line the hands up. I wanted to see if whether through the neck hole I could reach in to solder those wires onto the motor, and no, that won't be the way to do it. So let's pull the wires back through. I'm going to bring this table over with something to hold the body up. This will work. Here we go. Let's turn this back on. While that's heating up, we can take a look at one of these legs. So this side I guess I didn't glue either side down yet. So you can see if you lift this leg shell up, all of the pins are then exposed. These are, again, 3mm, and you're going to have to make 10 of those all total, because you've got 5. You've got your 2 ratchet wheels here, you got your ratchet arm, and then your 2 leg linkages. We're going to pull all that apart when we're done testing these motors, so I can show you how all that goes together and how it works. But I don't want to tear it apart till we hook these motors up, because I'll just have to put it all back together again, which will take longer. I'm going to trim these wires up. They seem to be unruly long. There we go. This particular case, there isn't really a right or a wrong on the motor direction. It would, in the end, the robot's going to walk forward no matter what, and, well, if you put the ratchets in right. All it's going to end up doing is changing the direction that the color wheel is spinning. So if you have a favorite direction, you could move things around. Again, if this isn't on camera, I'm sorry. I have to be able to see what I'm doing, but I'm almost done here. Alright, there's that. Let's put you back down on a low setting. Alright. We'll bring the body around. Just pull our wires up. Maybe I'll actually look at the arm linkages. There we go. Alright. So theoretically, this is the 120 motor. So it is faster. Let's see how it looks with the chest piece on. We have to quickly reassemble this because I took it apart, but that's just one screw. And again, we want to make sure the screw's in as far as it can go, but we still need the disc to turn freely. I think we're all right. Notice how the disc sticks up just a little above the top of this. when you go to put this on the body, horseshoe the top in first, and then drop the bottom side in. Oh yeah. Color change is much quicker. It's kind of cool looking. It looks like it was actually some sort of a Geneva movement at this point, because you can't really see the transition line as they move past the circles. So I would say the 120 motor could be used if you want a nice fast walking robot. By the way, when you do assemble all these, this would be one of the last pieces that you would want to glue in, and normally I think I would go in with just a small drop of glue, maybe here and in the upper corners or something. Maybe something that you can peel loose, not something permanent and hard, just in case you decide you don't like it. Alright, let's heat this back up again and let's try a different motor. Let's try the 90-to-1, see what happens. Okay, that's not quite warm yet, so let's, while we're waiting for that to warm up, we have to take this little gear off anyway. Let's get it out of the way. There we go. Now let's see if we're warm here. Yes, we are. Like that. Let's lift that out. That was the 120-to-1. The only 90-to-1 I have is one of the old metal gear ones. I didn't want to order anything, so I don't even know if this will actually fit because it's a slightly different size case. I gotta move. I need a flat blade. Gotta move this out a little bit. I pushed the cam in too far. Okay, it slid in there. That's good. Let's put the screw in, holding that idler gear in place. I don't know if we're going to be able to hold everything together here without a screw in the end of this one. It has a metal shaft. This gear might just keep falling off. But I guess if what we're mainly interested in is the walking speed, it doesn't really matter if that gear falls off. Get on there. It'll probably fall off. But till then, let's hook our wires up. Assuming this is still on. These tend to shut off after 10 seconds or so, and then you have to turn them back on again. There's one wire. Get the other one. Let's turn you down. And find a safe place to put it at. Alright, got that. Let's get the arm linkages lined up. There we go. Must have a rod sticking out a little bit because the body didn't drop down all the way. There we go. Alright, so this is the 90-to-1 gear ratio. And something jammed. I'm going to take this gear off, the one that was binding up earlier. So we won't have the front display working on this, but we can see the walking speed. Well, it's still not bad. So I guess even the 91, if you were going to go just for the walking, would be fine. Now as far as what the problem was with this gear not lining up, I'm not 100% sure, other than there must be some slight change in the position between these mounting holes and where the shaft is, because this gear seemed to be pushing very tightly up against my idler one and was binding. Anyway, that's the way it appeared to me. And if that was really the case, then I guess what a person would have to do would be to take this gear file, and you might have to reduce it in size slightly. I don't know about how much, because this is all new territory. I hadn't even tried this motor before. But, you know, take it down 2%, 4%, which means you may have to take your X-Acto knife and hone that out until it will fit back onto the motor shaft. But get it small enough so it isn't binding up with that little gear. Okay, so what's that leave us? That leaves us with a 48-to-1, which is the standard really fast motor. And we'll try that one next. I guess I can just lift that out of there and then unsolder this. Just drop that guy on there. That. Could be that these faster ones are working because they don't have as much power when they're running faster, and the load of the toy is just loading the motor down. I'm just guessing, but I really didn't expect them to be functioning, quite frankly. All right, let's put our idler gear in here. Again, it seems to fit fine on this one, so there is some dimensional difference on that blue one. Now you can get these 90-to-1 ones in the yellow case too. This is just what I happen to have laying around, so that's why we were using it. Okay, let's drop that down. Body's down. All right, 45-to-1. Quite fast. Let's put the front on and see if it can drive that. And if it does, how that looks. Oh yeah. They're really moving. So I guess you could probably use just about any one of the motors for this particular one. When we start talking about the other 3 variations that I did, some of them are more speed important. For example, the one with the Moire design on the front, or Moire, as you're supposed to say, or something like that. The slower it turns, the better the effect is on that with the patterns. But this looks like you could probably get away using either one of them and running it on 3 volts. Okay, what we were going to talk about next was the legs. What was going on there? We haven't really talked about that. Let's get them off the robot. Like so. There we go. All right, I'm going to lift the foot shell off, which means if I'm not careful, I'm going to end up losing the pin. So the foot shells are the same on both feet. There is a left and a right leg, but there's not a left and a right foot. But there is a front and a back. And notice the toe section is wider than the back. So when you go to assemble this, make sure you have the wider part facing what's the front. Now when I print this, it prints flat on the bed like this. I enable the organic tree supports, and it'll just put them around this inside edge in here, so when you pull it off, you just snap out a few tree supports and you've got a clean looking part. Works really well that way. Alright, so holding, I'm going to take this, let's start with this upper pin. This is for this leg linkage part. I'm going to push that out. These, how long are these? These are about 29 millimeters long. The whole point of these is they're going to be the same length as this width. You got to be able to drop the shoe cover over it to hold them in place. So you don't want them sticking out too much. Now that we pulled that pin, this leg linkage piece is free. There's one of these in both legs, and they're both identical. It's not a left and a right to them. They print flat like that, no supports. Well, now we got the bright sunlight coming through, putting stripes on everything. All right, now we free the leg up with this this upper one up here. Let's push that out. Like I say, there is a left and a right foot because they print on the bed flat this way. And again, I enable the organic tree supports because you're going to need them like in this upper part here and around this part here, and you're going to need them on this part right here. Like I said, I left this part separate because if I'd left it on there, then there would have been supports through all of that, which just adds printing time when we're clean up. If you feel like modeling the file and joining the two together, feel free. It's not hard to do. You can do it. Brings us down to the foot base. So on this foot base we have the two ratchet wheels. Only one of the wheels is actually being used as the ratchet, which is this one here, and you can see the ratchet working. Now there is a front and a back to the base. These are symmetrically placed, so you can see that these two holes are closer to the back. This is where we had our leg attached, and here's how we had the leg linkage. So when you go to assemble this, you got to keep thinking toe. Toe sticks out further, so you know that this is the front of this black piece. And this whole black piece prints flat like that, no supports required. Let's take one of the wheels out. Now on this rear wheel, which I'm going to pull the rod on right now, it doesn't really matter which way you put it on because there's no ratchet actually on it. There are these rubber O-rings. In this particular case, these rubber O-rings are what they refer to as 3/8 inside diameter, 9/16 outside diameter, and what they call 3/32 section, which is basically the thickness of the rubber. At any rate, you're going to print 4 of these because there's 2 in each foot. They print vertically like I'm holding it right now. Do not enable supports for that. You wouldn't like trying to clean them up, and you don't need any supports. Your printer can print the part just fine without it. And then you just pop the rubber O-rings on for traction. This next center one here, this is going to be for the ratchet. And there's a ratchet in each foot. It's the same file. It's not a left and a right ratchet. There's just one ratchet, but there is a top and a bottom. The extra part that's added on here, that's going to be aiming down when you assemble this, and of course this aims towards the toe, the front. When I printed it, it prints flat like this on your printer, which means you enable supports on this one edge right here. And very easily when it prints, you just take them and snap the supports off and the part's ready to go. Again, with all of these, whether you're using the 3mm rod or whether you're using an American 1/8 inch rod, make sure that whatever rod it's on, everything turns completely freely. If this binds at all, your ratchet's not going to work. So you may need to clean it out depending on your printer setting and what rod you're using for free rotation. Alright, well here we're now to the front wheels. This is the toe section and here's the wheel. Obviously you can see how these parts are angled. So you want it so that the ratchet can, when the wheel moves forward like this, can drop down, but if it tried to move backward, that edge is going to lock against it. So that's the only thing you have to remember on that. If your ratchet isn't working, just try turning your wheel around. And that brings us down to the flat bottom base part. Prints like that. There's 2 of them. There's not a left and a right, but there is the front and the back, as I already explained. Get the 2 holes up here where the legs and the leg linkages closer to the rear. Your toe section is going to stick out towards the front. And there you have it. That's how I oriented the parts to print. That's our test with different motors. It looks like on this particular color one you could get away with using any one of the motors that's out there right now. And gosh, just have fun with it. Mod it. Make it your own, and be sure to share what you do with the rest of the world so that they can learn from what you did and maybe do mods of their own. Oh, I almost forgot. I was going to show you these other two links here that I just recently found for the motors, just in case you want them. This is an eBay link, and as you can see it says TT gear motor wheel kit dual shaft. That's important. And then it says 1/220 reduction rate. And they're not cheap compared to the AliExpress ones, which were like $1 a piece, because you only get 2 of them and you're going to pay like $14.76. But it does say free shipping. So, in fact, that even says something about tariffs and crap not going to increase. Free shipping by seller. Price includes all duties and fees. You won't pay anything extra after checkout. So, again, I found this on eBay. If I think of it, I'll add the link. And what else? There is BC Robotics, which is in Canada. They sell one at a lower price. It's $3. It's the dual shaft, it said, and it's the 120 gear ratio. They're going to be charging you some shipping. I have never ordered from them. I simply found it for sale, and I thought I'd add that as a possible link. But I know it's got the dual shaft because they got a wheel on one side and they've got an encoder snapped on the other side. So we got the dual shaft, you got the good ratio. That's another possibility. I have no idea what the tariffs would do between us and Canada, if anything. Something this low cost, perhaps it wouldn't have any effect. I don't know.